Hello everyone and welcome to this webinar where we are going to present this new module that we have in our structural softwares about calculating sinking loads in deep foundations using concrete piles. I'm Antonio Castel, a member of the technical department, and today with me is Adriano Braguera, that is a member of our development department in charge of this new module. Hello Adriano.
Hello.
Okay, I think maybe after you can present yourself a little bit more on how you have been working on this new module lately. But well, this new module, it's a part of our new version that we published the 4th of November. We have a lot of new interesting stuff, so I invite you to go to our website and visiting the new features that we have for the version 2025C. Normally we publish 4 versions per year, and well, this one in particular is full of new interesting features. Okay, we're going to be presenting today this new module in 2 of our main structural softwares that are CYPECAD and Cype 3D. I'm going to give a little bit an overview of the module of all the interface of the foundation that we have integrated in our software, and then Adriano is going to go more deeper indeed on deep foundations. Okay, I'm going, for example, to open CYPECAD where I had opened this this example. Okay, in this example you can see how we combine both of our softwares, CYPECAD and Cype 3D. Okay, if we go outside, you can see how well a little definition of our CYPECAD software. That is a software for analysis and design of reinforced concrete, steel, timber, and aluminum structures made up by basically all the elements or all the main elements that are needed for the buildings. Okay, columns, wall, shear walls, beams, floor slabs that can be hollow, joist floor slabs, etc. And of course, we integrate in the same software foundations, footings, pile caps, and also mat foundations. Okay. So going out here, I'm going to show you, for example, in this case, this particular software that is CYPECAD, and if we go to our integrated extractor that we have here, that is the steel extractor that I was showing to you, and I edit it, you see how we can enter to the interface of Cype 3D. Okay, Cype 3D. Let's check the whole extractor. It's the software that we have for other type of extractor that are not based on floors or plans. Okay, this software is really powerful, where we can do well, we have implemented lately some features regarding to non-linear analysis, etc. And as you can see, these two softwares are integrated. Okay, if we go out again to our software for concrete, this project already is analyzed. If we go to project general data, you can see how we have selected in this case the Eurocode for concrete, but also for cold formed steel and rolled steel. And as you can see here, we have well, codes from all around the world. I think this is one of our main strengths. Implement all these codes. So in this case, we are going to work with Eurocode, but feel free to try it and to check if the code of your country is available in our software. Okay, AC, British Standard, Eurocode, and also other national codes. Okay, in this case, also we activated the wind loading, but we also can check with seismic loading, and of course with check the fire resistance of our structure. Okay, if we go outside, accept. We are going to focus today in the results, and mainly in the results of our foundations. Okay, let me first also show you the 3D view of our reinforcement that is being created automatically with the analysis that we made based on the analytical model. Okay, so if we see this 3D view of the analyzed structure, give me a second so it can be displayed. There is a lot of information here, so it takes just a few seconds. Okay, but as you can see here, the structure is analyzed according to all this information that we inserted in the software, but also the reinforcement that that is needed to comply all the checks, all the code needs. As you can see here, it's being created. So it will help us to generate these automatic drawings, but also in the case we want to have an IFC model of this reinforcement, share it with our colleagues, etc., and work in this open BIM workflow, it will be available for you, okay? If we go to the plant of the foundations, you can see how here we have the menu of foundations, and here in foundation elements, I'm going to, for example, show you which types we have. You see here that we have reinforced concrete footings, mass concrete footings, and also pile caps for single columns or for multiple columns elements. In the case of the reinforced concrete, you can check here that, well, we have several predefined types where after we can change the geometry, as I'm going to show you, okay? Same thing for mass foundations. And in the case of the pile caps, we have these types. And well, the selection of the pile, that is the new feature that we are going to be speaking today. Adriano is going to go well, deeper in this feature. Okay, so I'm not going to steal from them the opportunity to explain you better. If we go to edit one of these, for example, this footing, you will see how the editing menu for the footings is opened. Here you can see the details that are being created, and of course we also have this 3D view of the reinforcement. Okay. This reinforcement, the interesting point is that can be checked and can be modified. In this case, we inserted some top reinforcement mesh with bars of 16th. We also could insert also perimeter reinforcement. You can see how if we accept this this menu, well, you can see in direct how this reinforcement is modified. Okay, probably if we go to the code checking, you will see how some of the checks are not complying because, well, due to minimum geometric ratio, if we tell the software only to show the failed checks, you will see why it's not complying, and then it gives the user the possibility to do all the modifications. Okay, we can go to view the complete listing, and same thing we do with the foundations, beams, columns, etc. We can always export these reports in PDF, doc, etc. to reuse it for our projects. Okay, if we go outside, we can see how we can modify also the materials, okay, steels, and other different situation or information for the analysis. The geometry, as I told you, can be modified, and you can tell the software always to design for you. Well, do, for example, a complete design according to the loads that you have in the column and according to the checks that are mandatory according to the code selected. Okay, in this case, probably with the reinforcement that I showed you at the beginning would be enough. You can also block your footings. Okay, this is about the detail I'm going to show you later in the drawings, but I would like to show you first also other type of elements that are involved in the footings, that are the strap and tie beams. Okay, in this case, if I define a new beam, you can see how we can define tie beams, strap beams, or, well, beam with automatic balancing at the ends. Okay, if I edit this one in particular, you will see how a similar menu as the menu I showed you for footings is being displayed, where you have this 3D view. Only in this case, the part of the beam is displayed, but you have the opportunity to modify stirrups, anchors, and as we did with the footings, do these code checks or which checks have been done for this beam. Okay. If we go outside, I would like to show you, so I don't take a lot of time from Adriano, how we can display and how easy it is to generate drawings in our software. Okay. If we go to drawings, give the software a second because it's going to. Okay, now the menu of the drawings is being displayed. I'm going to delete these ones because I was doing some tryouts before the webinar. But if I go to floor plans, foundation reinforcement, okay, I will select also the quantity summary, and I accept I'm going to be displaying all the details of the reinforcement. That is one of the main strengths of our software. And you will see how, well, in a matter of, I think around 1 minute, because we have a lot of foundation beams here and foundations, is going to be displayed, okay? As I said, beside the drawings, the other main strength that we talk about a lot of times are the reports, okay? These reports that I show you for foundation are available for beams, for columns, for slabs, and, well, the drawings also. I don't know, Adriano, you have something to add by these couple seconds that I'm showing these drawings?
Yes, we're going to get into technical detail very profoundly. I mean, the pile calculation modulus is a very professional software we designed to satisfy all the needs in project needs of the clients. And yes, we've put in a lot of work, so we hope that the result is satisfying for all the clients and the project needs.
Thank you, Adriano. Just a good information just for this couple seconds that the software needed to generate all these drawings that you can see in the screen, okay? As you can imagine, all the footings regarding to all the columns that are in this example, the tie beam, the strap beams, reinforcement is being created in 1 minute. And as you can see here, well, with the element, all the quantities, okay? As you can see here, this information that is in the screen is not a fixed information. Of course, you can modify, as I show you, this reinforcement before generating these drawings. But if we print all of them, let's see this file and tell our software to display the file with the associated software that we have. That will be a CAD software, okay? As you can see here, we are printing a DWG. So if we click accept, the associated software that you have in your PC will be open, and all these drawings that are being generated will be displayed on it. So as you can see here, the same drawings that we had in CYPECAD are going to be displayed in this case on this viewer, okay? All this information is organized by layers, and, well, I think it gets or took a lot of information, a lot of time from the engineers that are sometimes losing time on these drawings, okay? So the productivity that we can achieve with it, I think is it's important, okay? I'm going to close it. Just finishing to show you how same thing. I think this. I know this is the webinar for foundations, but I understand that a lot of us are also interested on other elements. So how to show you that same thing we do with the foundations can be done for columns, for beams, and for also slabs. Okay, here you have the details of the columns that probably a lot of you are interested on. Okay, so Adriano, I think it's all for now. I will leave you now sharing your knowledge. Okay, I'm going to leave the screen for you. Give me a second. I'm going to make you presenter. Antonio. Thank you.
First of all, thank you for having me here. So for me, it's a pleasure to be here, to be able to present the pile module. And first of all, I wanted to say that we have put in a lot of work and a lot of development into this module in order to satisfy the client's needs. And in those lines, I would like to say what I mean by satisfying those clients' needs. So first of all, of course, we are doing the pile calculation, but this pile calculation has to do with a lot of, let's say, geomechanical formulas that are norm independent. So what do I mean by that? Like the shaft friction and the tip resistance is calculated with empirical formulas, and everything that is considered to the norm has to be also taken into account. So first of all, this is CYPECAD. Here we have a couple of foundations defined. This is for a building that looks like this. Okay, so here we have the concrete elements, the pile caps, the piles defined in a 3D model. This is an IFC file, which I will get later into it on how we can share these files, how we can interact with them. But first of all, let's go to the technical details. So here in project, once we have defined our structure, we can go to general data. And here in general data, we will have to define the norm or the code which we are going to use to define the structural element. So for now, we have incorporated all the Euro codes with their respective countries. So this will have an effect on how the loads, what coefficients are applied on the loads and what coefficients are applied on the geomechanical parameters the user is going to define. But then, of course, if you are from a country which is outside of the Eurocode or outside of Spanish norm, you also want to be able to calculate and to define the pile and pile groups. So what you would do is you would, for example, define your desired country. Let's go, for example, with Mexico. And then once you have changed the norm, you would go into foundation. And here in piles, reinforced concrete in brackets, you could define the security factors or the desired parameters you want to be applied on the geomechanical factors. You could change it by hand. So in reality, this calculation that we have done, it's done on purpose. So this is a module that can be taken into every country in the world. Basically, it's an international module. It just depends on the engineer to also put in the correct security factors so the pile is defined correctly. For now, let's go.
Adriano, sorry,
Yes.
one fast question. I know that it can be applied to a lot of codes because it's generic. The engineers should introduce these safety factors, but the factors that we give by default, I think these factors are in the side of the safety, right? Always.
Exactly. In case it is not defined by the user, the safety factor will be defined as 3. So the applied loads divided by the resisting loads is 1/3, or in reverse 3. So yes, this is always Cype decides on the safety of the structures. So this would be no problem, even if the user doesn't define it correctly.
Okay, thank you.
In case the Eurocode is defined, the safety factor, it's like, let's say it's a more efficient way of calculating the piles would be around 2.2. This is what we have calculated in comparison to the safety factor of 3. So it's a more sophisticated approach to calculating a pile, but it's also, yes, it has to take less safety measures as a consequence. So we apply the Eurocode too. Now, we would have to define the level in which we want to incorporate the structural elements. In this case, we are at the foundation element. And now we would just go and define a pile cap and a pile with different types of soils. So we go to foundation elements. This window will open up. We click on new. And here, as Antonio said before, we have the different structural foundation elements we can define. We would go to pile cap. Here in selection of pile cap, we have the different types of variations we could have. In our case, let's just define a pile cap with 4 piles. We would go into selection of the pile. Then in this window, we have the generic definition. This is like the part of CYPECAD that was already defined. And now this is the new module we have defined, in which we would have to go through and define all the geometrical details of the pile. So let's call it reference P1. We would design a circle pile with a diameter of 400 millimeters, a length of 6 meters. Penetration is the amount or the distance the top of the pile penetrates into the pile cap. In case this is not clear, here on the interrogation sign, on the question mark, sorry, we have a little drawing in which we can see LT is the length of the pile that is in contact with the soil, while LP is the length of the pile which is introduced into the pile cap. And then we have to define the type of pile. So we have a precast driven pile, or we have an on-site concrete pouring pile. In this case, we would take this one. And then we have to define our soil. So we would go to new. Here in reference, we would input, for example, soil 1. And here we can define the different soil layers we would apply and which will be saved in soil 1. So let's click on the plus. It opens up this window, and this window we can either define between cohesive soil, granular soil, and rock. Then it would ask the user the geometrical parameters. Also, you can choose the color selection that is going to be shown in the soil detailing, or you can choose the weave selection, which can be changed here. Or if we just want to do an example test, we could just go to the library on the blue arrow, and this would open up a library of predefined soils we have already inputted into the program. For example, let's go with dense sand. We'd input dense sand. We'd click OK, for example, 3 meters. And now we add another soil. In this case, limestone, another 3 meters. Oh, yes. Okay, limestone would be a rock. In case it is a rock, we have to define different geomechanic parameters. In this case, we have to define the simple compression resistance, the spacing of the discontinuities, and the opening of the discontinuities. And then we have another checkbox, which defines if we want to consider the stiffness of the rock to prevent the displacement of the pile. And this, as a consequence, wouldn't allow the shaft resistance to work. So in case we have this check marked, the pile would only be working through the tip, so only tip resistance. This is often used because the rock, like let's say the pile is applied on a hard bedrock, the pile wouldn't be able to mobilize any displacement. And if there's no displacement, there can be no shaft resistance or shaft friction. So this is something that was asked by our users, and we had to implement it into the program in order for it to be fully satisfy the needs we have on different projects. Once this is defined, because we are working in a library, we also have the option to export this defined soil layer. Then we would go to this red arrow, and we would, for example, say, okay, I have defined limestone 1. I would save this in a desired folder. For example, let's go just for now with a desktop. I would say this is limestone 1. And then once I have exported it, I am also able to import it again. And I have like a display menu here with all my defined stones, and I could re-import them into the software. So this allows to not have the user do repetitive definitions of soils and materials. So if the user has different projects in which these materials reappear, he can reuse them from previous projects. Yes, so right now we have defined dense sand, limestone. Let's go define a different soil also. Let's go, for example, with some hard clay. Here we can see that it would be a cohesive soil with already a density. It has a compressive resistance, and both the effective internal friction angle and the internal friction angle to consider the short-term effects the soil has on the pile or the long-term effects. So once this is defined, let's do a thickness of 12 meters. We would have defined our soil. Now we accept this. It would be introduced into the module. Now we can also define a displacement between the piles. This is important in the case we are going to be defining a driven pile, because for some reason, sometimes the pile breaks or there's a problem driving the pile. So usually the old pile remains, a new pile is driven right next to it. And then the calculation has to also adapt to this small project changes on project site. So we would have to introduce a displacement in this window. For now, we just leave it as it is. And with this, we would also already have defined our pile. Click on accept. And now we can, with a small left mouse click, attach this pile cap and pile we have defined with its soil to the position we wanted on our project. Okay, now once this is done, we can go to edit. We can click on our element, and now this panel opens up. So in this panel, we have the same as before we had in the pile cap definitions. We could change these pile caps if we would like to. Also, we have material definitions. So in case we want to change the concrete or we want to change the steel, we could go into this menu, change the desired specifications. We could also consider soil structure interaction. So this means if we view our entire structure as one, and we want to not only we want to consider the stiffness between their interaction of the concrete structure and the soil in the pile caps, we could go here and define, this is more or less like a rigidness we could define here, axial stiffness of the pile. And this would also be taken into account when we're doing the seismic considerations, the seismic calculation. This would also be taken into account. For now, we just leave it as it is. Then in piles, we have the same editing we had before, where we defined our element. Then in geometry, we could change the geometry of the pile cap, the overhangs, the depth. Then we can change the reinforcement. Here we have the reinforcement options, the top reinforcement, bottom reinforcement, perimeter. This could be also defined here. In our case, we are not going to use this because we're going to do an automatic calculation of the concrete geometry and the reinforcement geometry. This is a big feature CYPECAD has, that the user doesn't really have to be thinking about the geometry of the element. It's going to be automatically dimensioned in the software. And yes, we also have the code checks here. So once we have calculated our structure in the code checks, if we go into here, we would see the different considerations of the pile cap, and also on the piles we would have the verification. Now it's saying there are no loads acting on the pile cap. This is because the structure is not calculated as a whole and has to be calculated in order for the loads to arrive here. So for now, we accept this panel. We go to analyze, and we would do a brief calculation of the loads. So we go to project analysis, except foundations. This will take a quick moment. Of course, this is faster than by hand. So this is going to give us a final design report. Okay, for now it's saying the soil structure interaction has not been considered because I deselected the check mark, and it doesn't seem like there has been a problem in the calculation. So I can continue and see what loads have arrived at my foundations. Go for foundation elements, edit. Now we go back to the same verification we were checking in code checks. Now we see, okay, I have some verified checks and a small error. We will continue to afterwards to why this is. And in piles, we have both verification, compression and tension verification. Compression, this would be the full report, and the tension is not being considered because there is no load combination considering a tension on the pile cap for now. If this was the case, if there was a combination, for example, through wind loads that is generating a traction in the pile cap, this would be considered here, and you would have a pile group only working through shaft resistance. So let's go to the verification. This is the compression verification. For now, it says we are at 41% of the maximum capacity of the pile. This is the full verification. Then we have the calculation of the efficiency factor of the group. This is done through the formula of Converse-Labar. Of course, in every formula we have introduced, we have also the reference to the literature. So If something is unclear, the user can always check in the literature to see where the formulas are coming from. So we try to always give full transparency on all our structural software calculation in order for the user to be able to verify where all the results are coming from. So we have the calculation of the efficiency factor, then the sinking resistance, which is going to be made from the shaft resistance and tip resistance. And then, of course, all the layers we have defined are going to have a contribution to the shaft resistance, which is detailed here. For granular soil, we have our formula with a literate definition. For cohesive soils, we have the formula. So this is a very clear and structured way of proving that the pile has been calculated successfully. Okay, and this is the calculation of the tip resistance, also having into account the passive zone, the active zone. So it depends on how the soils were defined. The pile will do the automatic calculation to verify that the pile has correctly been defined. Okay, and coming back to this module, I would like to also show the 3D view. So now we have already a calculated pile cap, we have the reinforcement, and now, of course, we want to share this with others. We have different options of doing this. So, for example, we can make some cuts here. We have these options to make some cuts. For example, let's see what is going on here. We can do a small turnaround to see, okay, what bars are interacting here. Also, if I don't like this, I would like to do some more cuts. I can just point in here. I can do some modifications to what is being represented in the 3D view. When I'm rotating, I'm getting the full display of what's going inside. And then imagine I'm doing this for a report, or I'm just doing the calculation in CYPECAD. Now I want to take this to Excel or to Word, where I want to finish my calculation report. I can just use the options I have here. I can export this as a DXF, as Antonio said before, in 2D, in 3D. I can generate a GLTF file, which is the exact same representation of this 3D model. Yep. Also, I can do a JPEG in which I can input, for example, the amount of pixels I want to export. This is, for example, let's do a full HD output with 1920 by 1080. And let's just save this on desktop as report.
Yeah. We don't normally, Adriano, I think we don't speak a lot about this feature, but I think it's really important and interesting sometimes for the daily work, in case you want to insert images of your project, etc., or sharing with your colleagues. Yeah, sometimes the DWG 3D or this simple image, I think it's quite interesting. Yeah.
Let's see a report. Let's search it on the. Here we would have the screenshot. Now we can see that this is a very high quality screenshot that we can import into any further software that we would like to define or reports with. Yes, so this is basically the part we have in CYPECAD. Also, this module is integrated in our software Cype 3D. So in Cype 3D, I have defined a little bit of a different structure. For now, we have like a solar panel structure in which we're going to be defining different foundations. Right now, we can see just a normal concrete foundation. Here, I've defined something with piles already, which would be the left side. And just as a demonstration purpose, I would just like to go and show you the process of how the piles are defined here. So we would go to New. Here we have a window that says pile cap, which is the case we want to define. And now in pile caps, we have it's compressed into the definition of the pile and to the definition of the pile cap. So here we choose the desired pile cap. Let's go with 3 piles. Let's go with P2, circular. Let's do 300 millimeters, pile length of 6 meters. And again, a penetration of 10 centimeters. Now we're going to do a a precast-driven pile. This is going to have an influence on the verifications we're going to do later. And here we have a terrain which has been defined with gravel with a thickness of 30 meters. Okay, this is perfectly fine. If we go into this icon, we can also see the defined soil with the water table, which can also be activated here, which also has an effect on the verifications that are going to be applied on the piles. For now, we're going to activate this. Let's go in, for example, with a level of -2 to see how this affects the calculations. It's going to have an effect on the effective stress. We're going to accept this and input the pile cap, in this case, for both pieces. Of course, this is totally over-dimensioned piece. It's just for demonstration purposes. And yes, now we would have defined our pile with our pile cap. We would go to, now we have, the loads are already defined. We go to pile cap, edit, and now we have the same panel as before with our material definition, pile definition, geometry in case we want to change it, the reinforcement. Also, we could mention the design options. So in design, we have 3 different ways we can design the piece. We can do a complete design, which would mean loads are arriving on the pile cap. We're going to dimension the concrete element, the dimension of the geometry of the concrete elements. We're going to design the reinforcement that is in this concrete element, or we can go to minimum dimensions. In this case, the user-defined geometry is going to be verified, and in case that it needs to be it has to be redesigned and made bigger, this is going to be automatically done in the program. Or we're just going to go with redesign, in which the concrete dimension are fixed, and we're just going to redesign the interior reinforcement. In this case, the best solution, even though it takes a little bit longer to calculate, I would go with a complete solution, which is always going to try to find the best and optimal solution for our building site. Also, what is important to mention is this is a type D element, so this is not considered as a beam. This is the theory of Bernoulli does not apply here, in which you can take the indeformability of the faces. This acts as a very rigid body. So in this case, this has to be calculated with a strut and tie model. In this case, if we click on strut 3D, we can see what exactly is going on and where are my values and the solutions coming from. So this is the strut and tie model, which is going to be applied. The loads are arriving here. It's going to set up this triangular shape, and a load is going to arrive at the piles. And all the combinations that are done in order to, well, the combinations that are applied on this model in order to obtain the resistance of the pile. And for now, if we go to the nodes, we can see what coefficients are applied, what force is in the element, and what area is assigned to the element. And also, if we go to the node, we can see exactly at what coordinates the node is and what force is arriving at the element. I think this is also a very good tool in order to verify what is going on in the calculations, as this is often asked by our users. Well, what strut and tie model are you really using? So if you have questions regarding what is going on in order to obtain the reinforcement, here you can find all the answers.
Yep.
Yes, and this is basically what I wanted to show in terms of the piles. Now I would like to also show, now once we have defined our piles, pile cap, our structure, I would like to show the common data environment Cype has to offer in terms of BIM. Okay, so we would go to CYPECAD. We have defined our 3D model. As we showed before, we had this view. Also, if we go to the result tabs and we go to the 3D view with details, and we click on accept, now it's going to build a whole 3D model with all the details and all the calculations that have been done. So right now we would see that we have our concrete elements with our reinforcements, And now I would like to share this model. Why? Because maybe there's someone at the building site that wants to know exactly where the reinforcement has to go, and I want to send him this file. So
yeah, or Adriano, or collaborate somehow, right? This model
yes,
can be shared, for example, with a plumbing expert, and then a plumbing installation can be defined over this structure in another software of our suite, for example. Yeah.
exactly. This has so many different applications. Yeah. This is like the digitalization of the construction sector. And here at Cype, what we're trying to do is to improve the 3D workflow. So once you have this 3D model, it opens a lot of opportunities for all other collaborators in every type of sector to collaborate in your project. And we at Cype, we provide this platform, which is called the BIMserver.center, in which architects, engineers, as you said, also people that are involved in plumbing or in any type, everything that has to do with the construction process is able to incorporate their commitments to this common data environment, in which we set up this 3D module, 3D model in which we can see everything that is going on. So for now, we would go to login. I would connect the software with my BIMserver account. I would click on allow. This now it allows me for my project to be allocated in this common data environment in the BIMserver.center. And I would like to share my structure with my detailings, with my concrete elements to the BIMserver.center. Here I have so many different options to what I want to share. I mean, I can have the reinforcement shared or not, analytical model, the quantities. For now, we would just go with the reinforcement, the analytical model. I will share this on the BIMserver.center. This will take a couple of minutes till a couple of seconds, sorry, to have this information uploaded in the BIMserver.center. And once it's uploaded on the server, which is completely free, has no extra charge of cost, other users can go into the different projects I've defined. In this case, the pile project. I can go inside here and I would have my structure commitment, which I have uploaded here. I can go inside of it. Let's go to 3D view. And here I have the 3D view of my entire structure now. Of course, now this is in process. This is going to take a couple of minutes till it uploads. But once it's there, I have a lot of different types of options I can introduce. For example, here I have the model. Let's say the different layers of the model. For example, I have my reinforcement, which is saved in a GLTF file. Then the analytical model, which we also had as an option to share. And of course, the GLTF of all the concrete elements. And so much more options like to lightening. I can center the model, I can turn it, I can make cuts. I have information on this model also, and this part of the taskbar. I can do animations in which I can turn the model, but also not only that, like I can go into the structure and I have here on the right side, I would have a lot of documentation I could also upload. For example,
it's in the center, I think, right? Or, I mean, in the center of the image, and then the contribution.
Yes. So and also I can recommend this. I can share these contributions. I can also invite other people. For now, I could, for example, as a collaborator, I could invite Antonio. So we go to Antonio and search him on the BIMserver.center, and then I would be able to share my project with him.
Yeah, I think I am already a member of the project.
In case this user is already in the project, we could also use a link. We can take this link and share this link. So we could, in reality, we could invite any person to the project.
Yep.
If we go back to the 3D view, Also, this serves as a platform of also downloading the EFC file. What we have done right now is to take the software, we send the EFC file to BIMserver.center, but also now you can go and download these files or upload another commitment and upload another file. But for now, let's see what we have uploaded here. So we go on visible, accept. Now we would have a definition of the different IFC models we have uploaded. If we, for example, are only interested in the reinforcement, we would of course select the parts of the model we want to be visible. So for now, let's imagine I got a call, I'm a structural engineer, I got a call from the building side. I want to see what type of reinforcement is going to be applied in the pile caps. Maybe I also get a very specific information. It's telling me, I just want to see the reinforcement on the pile cap of the corner. I would go here and I would have a full control over the visibility of the reinforcements that are in our building project. For example, I can go to information, I can click here and it would give me all the information of what exactly is going on here. So I get the reference of the bars, I get the material of the steel that is defined for the bars, the diameter, the length, the weight, number of bars, everything that is really needed. And also this comes in handy for some sophisticated definitions of animations. So here we can see how the animation would work. And this is just a very attractive way of showing other people the structure that you have defined. Yes, so basically that's it from my part. Antonio, I would give it back to you and you take it from there.
Thank you, Adriano, for your detailed presentation.
Yeah, of course.
Yeah, I think this model is quite interesting. I also think that we have a little bit of time, and we could comment why I'm again in this project, right? I'm in BIMserver.center, and as Adriano was showing us, you have the part, the side of the professional projects, and then you can see how I'm in Adriano's project, because in notification, Adriano was actually inviting me to this project, okay? If we go inside this project, you can see how Adriano is the owner of this project, but I can access to this contribution. I think Adriano were clicking here before, but when we click in the middle of the image, you can access, as Adriano was showing, to the different documents that are generated with the upload, okay? The structure in GLTF, in IFC, etc. And then all these files can be downloaded. The native project is being, well, Adriano is the owner of the native project in CYPECAD, the structural project. But then we can, for example, download this IFC, and with other tools like BIMvision, for example, we can open them, and you can see how all the data that we upload here is synced to work with open sources such as, IFC, GLTF, etc. This is how our platform works. You can see that you can send these models to other platforms that also allow these IFC models that are also, of course, organized such as a proper IFC. Okay, I'm going to close this, and I think we also wanted to show you before how can it work, for example, in the case of the virtual reality or augmented reality. We have other little tools that are involving these new tools that are in the market. Okay, so I think was here in time. Let me try to share my screen with my phone so I can show you directly in my app, BIMserver.center application, how it works. Okay, let me connect. If it's going to work. It always happens these kind of things. Let me check. Okay, projecting. I don't know why it's not working for me now, sorry. But if not, we can close here and then we will show you in another moment. System. Let me name this PC. What? We won't do this time, Adriano, I think. I was trying to prepare
Okay, no
it,
problem.
but yeah.
Let me just show for a moment. Let me come back to my screen.
Okay.
I wanted to show
plan B, right?
Yes, just to show what so BIMserver.center, of course, works also on the phone. So there's the app you can download. I just have a quick quick video that I did with my phone, in which the same model and which is already uploaded to the BIMserver.center can be accessed through the BIMserver application, which is available for Android and for Apple. And this just serves as a view, as we were talking before on the construction site, where the construction manager can just take his phone, he can view the different rebars he has in his model, and he can also zoom in and show what exact rebars are in the pile cap at the corner. And as we were mentioning before, all the different functionalities that we were showing also are here. For example, you can click on information, you can click on the bar and it would say corrugated bar with the reference number, with the materials that are defined, the diameter, the length. Everything is in this common data environment and is free for every collaborator to be viewed and to be used in the project. Yes,
okay.
That's basically what I wanted to mention in this aspect.
Yeah. Thank you for having this B plan, connecting all the PCs to the phones, etc. Depend on Wi-Fi always. So we're trying to show it to you, but not working this time. Okay, I think Adriano, we spoke about everything we need in this module. I think another thing we should comment is about new features or new modules that are going to be involving these deep foundations, right? As you will see in the model Adriano showed you, yeah.
So first of all, the first module, which has been released in the version 2025C, is involving the calculation of the sinking resistance in pile and pile groups. For the second module, we're going to have the verification of the reinforcement that is introduced by the user into a pile, for example, also the pile cap, as we have shown before, it is already verified. But now this feature is going to be advancing onto the piles. The user is going to define the bars there, and the verification is done with a minimum momentum that is also going to be introduced by the user. And in the third part, the third module, which is going to be released, we are going to have the verification with horizontal loads in OpenSees. This is going to be a module which is going to be released with the OpenSees, which is a finite element analysis software from I think the University of Berkeley. And this is going to be the third and last module, which is going to be released in terms of pile calculations.
Okay. I think it's good sometimes, right, to inform our attendees, our users, that we are working hard on getting better in a lot of features. And well, this is one of those. Probably, well, now we included this very interesting feature, but the module for foundation that we'll have in the future versions is going to be amazing. And well, having the possibility of dimensioning, designing all the structure, of course, these elements, column, beams, slabs, but also the foundations in all the same structure solutions, I think it's interesting. Okay, so yeah, we invite you to come here to share our projects and to check how our platform works and our software. And for me, I think it's all. Adriano,
yes.
Thank you very much for presenting these new features. Thank you all for attending this webinar. We will have more in the next day, so we invite you to check our agenda in our website. And again, thank you for attending.
Thank you for having me, Antonio. Bye-bye to all our viewers.